Hello and welcome. Today we're going to learn how to make what an associate has called, and I like the name, cherry gold. This is 150 parts per million nanoparticle gold created with the infrared laser in about 30 minutes or so. I'm going to show you how to do this from start to finish. Now, there's a lot of little things with the infrared laser that you need to know in order to make things easier in the beginning. Things I didn't know and kind of pulled my freaking hair out trying to figure out, well, why isn't this working? So this will make it your journey a lot easier if you're using the infrared laser for the first time to make nanoparticles. The blue laser was much simpler, let's face it. Put the sample underneath the water, put the height on 4 millimeters above the target, turn it on and wait for an hour or so or two, depending on what you were making, and you had your nanoparticles. But with the infrared laser, we can make really high concentrated stuff. With the blue laser, we're limited to 20 parts per million, maybe 30, if we really want to put the work into making it go longer. But with the infrared laser, we really can cram a lot of stuff in the fluid. Now, just to note, at 150 parts per million is pretty packed up. And according to the AI and the research that I have found, you really can't go above 150 parts per million for any of the materials that we're going to be creating nanoparticles with. There's just not enough space in there to go above. I mean, you can cram the material in, but it's going to fall out. You'll have like stuff in here, dark stuff in the case of gold, but in the case of like zinc, you'll have white stuff falling out of the liquid. So you're not going to get any more than that. So my advice is let's stick to reasonable concentrations. Let's talk about the software. We can't make nanoparticles without software. And software becomes really important with the infrared laser. So the laser that I have comes with G-Laser software. And it's manufacturer supplied software, and it works just fine. But the G-Laser software has got other settings than the blue laser, which just really has power and speed. We have power, speed, passes, a number of times it's going to go over a layers, and we have frequency. Frequency is like what color you want to engrave the laser in. You can draw pictures by varying the frequency if you were doing metal. You might have a light tinted color or a dark tinted color, and what we're going to use the frequency for is just optimizing our nanoparticle production. Now, I have a complicated 6-layer setup that varies frequency, speed, power, and passes to give a maximum amount of nanoparticles with minimum amount of material. But if you're just starting out, that's way too complicated. So I'm just going to suggest, I'm going to show you what my 6-layer setup does, looks like, the chart. But I'm going to suggest you just do 1 layer for now. And I'll give you this basic settings for 1 layer that'll get you creating nanoparticles so you can say, wow, okay, I did it. And then maybe I'll do another show on my 6-layer setup, exactly why it does what it does, and how you can make this 6-layer setup, because the software is a little bit complicated in that respect. And I don't want to complicate this video too much, which is already a long video covering a lot of different things. So just take my settings, my 1-layer settings put them into your laser, and it will get you started with the process, and then we can move on to other things. Now, I use a crosshatch pattern. a tag crosshatch pattern. The laser software will not work with bitmaps, unlike our blue software, which did. So what we need to do is we need to create vectors of whatever you want to use to etch on your surface of your thing. You need to create it as a vector. We're just making nanoparticles. The crosshatch pattern works good. In the beginning, I used a spiral pattern, which actually came with the software. It was a vector spiral pattern. Looked really cool, but gouged the hell out of the metal. Used a lot of material. So now I use a basic crosshatch pattern, which is one of the text figures. And I'll show you a picture. This is the text figure that I use to create all my nanoparticles. Most of my nanoparticles. Copper, I still use. Copper is really hard. I still use the spiral thing for that. But anyway, for gold, you need the crosshatch pattern. And just put this, type that in, set up, go into text, and get that, copy that figure from your clipboard, your text software, copy it into your clipboard and paste it in there, and then resize it to the size that you need for the laser. First, how about we cover the basic setup? You need a piece of gold. I have my piece of gold mounted in this little container, this little thing here. This is a 1 gram piece of gold. And this is my rig. I mean, if you watch my other videos, you've seen this rig. And this goes in the top like this, which we will fill with the stuff, the fluid that we need in order to make gold. Now, with the blue laser, we pretty much had to use this sort of setup. And I still use this setup. But it is possible with the infrared laser to not have to use this tray. You could take your sample, whatever you're making, and put it take a beaker, put it on the bottom of the beaker, and then focus the laser, put this whole beaker on the infrared laser platform, and focus the thing down here. And I haven't tried it because I like my method with the stirrer. It's much more efficient. If we agitate the water and make it move around, it will create nanoparticles much more easier. And I had the rig all set up. But for those of you that maybe looking at my setup saying, oh, gee, I can't do that or whatever, you could do something like this as well. The problem with this, of course, is the shifting of the metal in the bottom. With this piece here, this piece of silver, it's pretty big. So you're not going to get a whole lot of shifting going around in the bottom. But with the small 1 gram piece of material, just kind of light, it could move. And if it moves, well, you're not going to do anything with the glass. Infrared laser goes right through glass. It doesn't etch glass or anything like that, supposedly. But you will etch the bottom of your laser, the metal bottom of your laser. You will etch, and I've done that. I've etched stuff into the bottom of my laser. It etches real easily. It's an aluminum base. And so I prefer a way to fix the thing permanently in there where it's not going to move. But I just wanted to point it out that it is possible to do it that way. Regardless, it starts with a beaker and a sample of your whatever it is you want to put in here. Now we're going to fill this with distilled water. You can also use RO water in here if you want with plasma arc, and we really needed to use distilled water because we can't create an arc without pure water. With the laser, it's a lot more forgiving. And RO water comes in at about 6 to 8 parts per million, which is virtually just about distilled water. Distilled water is 0 parts per million. So you can get away with using RO water for your nanoparticle use with the laser. I would not use spring water or any of the other things because the mineral content is going to be high and it's going to influence the final result of what you get, because you're going to have these other complications going on with other minerals in there. The next step is to prepare the solution for our nanoparticle use. Now with the blue laser, we could just get away with just using distilled water in most cases, but because we're going to be cooking to a higher concentration, we need to add a little bit of sodium citrate to our solution in order to increase the electrostatic charge in the mixture to keep the nanoparticles apart from aggregating into larger particles. And so you will have to add a little of that. Now, this is 5 milliliters of sodium citrate, which comes out to my stock solution. And I show you how to make stock solutions in another video. So I'll link that in the description if you're looking for that. But basically, it's 75 milligrams of sodium citrate. You could use the powder if you want. Just make sure it's all dissolved. I like to have it all dissolved, pre-dissolved, and I will just pour this into my thing here. The other thing I like to add, because it does help with stability on all my nanoparticles, is silicon. This is monocrystal silicon that I made, nanoparticles, which is part of one of the nanoparticles that I actually make. And I will put 6 drops of this in here to increase the its ability to stay together. The silicon acts as a kind of glue, which helps the nanoparticles not come apart. Another thing that adds stability to our mixture. Now that's 60 parts per million silicon, if you're wondering what I've cooked that to. And so you'd have to, in order to use the silicon first, you'd have to cook the silicon before you're going to do the gold, but you don't need it. It's just optional. It adds a little extra stability to all of your nanoparticles if you have access to silicon and you want to make that. If not, don't worry about it. The next step is going to be adding the distilled or RO water to the sample here. I fill it all the way to the tippy top, trying to get the most in there. And now we will take the sample and put it into the laser, which I'll show you a video of doing that. As you can see in this video, this is my infrared fiber laser G2 Gawicki, I think I said that right, laser. And as I have the stirrer underneath and the laser raised up so that I can fit the stirrer underneath and then the sample on top of the stirrer, which keeps the stirrer going, and then the metal is even, though you can't tell, it's actually even with the plate, the top plate. And that's kind of important with this kind of laser. The laser requires 230 millimeters in height above whatever it is you're going to etch. Unlike the blue laser, which needed 4 millimeters above the surface, this laser requires a much wider range. So that enables us to get bigger beakers underneath the protective screen that's on the laser, which is good for us making nanoparticles. I mean, you don't actually, I have a cover that I put over my thing because you don't want the infrared light leaking out from the bottom. As you can see on the bottom of my laser, I got a cardboard box around it to keep the stray infrared light from coming out, which you actually can't see. If you were just going to not use the stirrer on the bottom and just put your beaker on the tray, the metal tray itself, you because of the shield that comes down on top of this particular laser, you wouldn't need to have the box or any of that stuff. But because of my setup, I need to do it this way for eye safety. And of course, I always, even though I'm using, the laser has the green thing on it, the protection, I still try to remember to use these every single time. It's just an extra level of protection when I'm looking at the sample while we're engraving it, which becomes really important because I have to talk about the height of the laser, which we're going to talk about next. Now, the height of the laser is really important on the infrared laser. On the blue laser, we adjusted it to about 4 millimeters above the surface, and there really wasn't much else you could do with that. But with the infrared laser, a 0.5 millimeter either way will make a difference on whether you actually will start removing material or not removing material. And the infrared laser has got adjustments. Mine's electronic. It has an up arrow and a down arrow. And you have to move it up and down a little bit in order to get the correct height of 230 millimeters. So it has another feature, and I'm sure most of the infrared lasers have a feature. It has a positioning feature. It has two pinpoint LED spotlights that will show on when you put the sample underneath the thing. You'll have one LED spotlight, that pinpoint, that will go to the direct center of whatever it is that you're targeting. And then you'll have another one which tells you the focal point or the up and down of this laser. And what you have to do is adjust the up and down until the 2 points of light are almost together, are together. And really, with the nanoparticles, it needs to be a tiny bit below. So let's say the target height is 230 millimeters. The actual best thing is like between 231 millimeters and 230 and a half or something like that. So now we're getting really close to actually making the nanoparticles. But we're not done yet. We need to make sure that our figure fits onto whatever it is, that piece of metal that we are actually engraving on. If it's a big piece or a little piece. I would recommend you don't use anything larger than 10 millimeters in size, because then the laser lines are going to get pretty far apart from each other. But I mean, some of the smaller pieces of metal, like our piece of gold, is really tiny, and it's like 4 or 5 millimeters in size. And it's important that we don't overshoot. We want to make sure the pattern is going to be on the surface of the material. And thankfully, the infrared laser has a feature. It's called a red pattern. And what that does is, when you click the red button, the laser doesn't engage. All it does is put the red LED laser pattern on the screen, and it will draw a box around where the laser is actually going to be firing. And so you want to make sure that that red box encompasses just a little bit smaller than whatever area metal that you're doing. And unless you're doing a large piece of metal, in which I really recommend you don't go over 10 millimeters in size with the pattern. But for most of these, for gold, you're looking at a 1 gram bar of gold, which is pretty small, and you don't want it overshooting the thing. So make sure the square is well defined and in that pattern on the gold bar, probably a little bit smaller than the gold bar itself, before we engage the laser. So now we come to actually pushing the button and making it go. Now my laser, and I think most lasers, have a special button that you gotta pre-press in order to engage the laser power. So make sure you press that button when you get ready to actually mark. They call it marking the material. And there in the software, there's a button that says mark. And when you push the mark button, as long as you got the power button on the laser, you will begin to make your laser pattern. That's when you have to get in there and raise and lower a little bit make sure you're wearing your glasses, raise and lower the laser a little bit until you see the bright flaring pattern showing that you are etching the material. Then you just leave it go for however long you're going to leave it going for, and then you come back and check it, which is what I'm going to do here with the sample we just doctored up and got all ready. And then we're going to open up the cover and put it in the microscope and see what it looks like. So as you've seen in the beginning of the video, this is our cherry gold, which came out of the laser. On the video microscope over here is a picture of the nanoparticles that are in there, which is over 100 parts per million, probably about 150 parts per million. Now, I know a lot of you guys do not have a laser microscope, so you're probably going to have to use the manual method, which is the laser. Let's see, get this turned right. Notice I got my glasses on, and you'll see there's quite a lot of nanoparticles in here. Tons and tons of very tiny nanoparticles, which I would venture to say is around 5. Some of them are 5 nanometers. Some are going to be 10, 15. It's between the 5 and 30 nanometer range particles that I have in here from looking at it at the video microscope, which is actually really, really good, because having the extra range of nanoparticles is probably better for the body than just having one particular size. At least that's my thinking these days. I mean, 5 nanometer particles are nice and small, but there might be reasons where we need like 20 and 30 nanometer. And the color kind of suggests that we have a whole different conglomeration of sizes in there. We don't have, we don't have the red, ruby red that you would see if we made it with low voltage electrolysis. We don't have bright purple either. We got this nice cherry color gold, which is somewhere around around the middle way. And my preliminary tests on this gold is it's far superior to the blue laser gold, and far superior to the ruby red gold, or even the plasma arc rose gold that I had made. I mean, quite honestly, this stuff is potent. It really, really is powerful nanoparticles. So much powerful that I'm experimenting with nasal spray at full strength with it, as opposed and various other things like doing 30 and 40 parts per million teaspoons. So that's our video, our start to finish. I know it was kind of long, but there was so much to cover in there. I've delayed making the video for a while because I wanted to make sure I had everything all done and figured out in my mind on what I needed to tell you to use this laser. It's not as simple as the blue laser. But I think those of you that do endeavor to use the infrared laser will be very satisfied with the nanoparticle quality that you are having. And there's also the debate on infrared technology in general, that the infrared technology makes better nanoparticles because that force field that surrounds the metals to create the nanoparticles is going to be composed of infrared spectrum light. And the infrared spectrum light is very good in the body for kicking butt on the bad stuff and giving lots and transmitting the good stuff into the body. So, have fun, wizards. I will talk to all of you later. Have a way cool day.